Welcome to Science Sci-Fi, connecting the public to science and technology through storytelling. My name is Rones Friedman. I'm a science fiction writer and an IT professional. On January 1st, 2023, 60 Minutes interviewed Paul Ehrlich, an author of the 1968 population bomb book about overpopulation and why overpopulation is dangerous to people and to our planet. I encountered quite a few people who have a similar argument and use this as a reason why they don't want to have kids. It's bad for the planet. At least that's what they say. Part of the information in the 60 Minutes interview has been proven wrong over the years. I'm making this video to counter some of the arguments in the video, in the 60 Minutes TV show, why we do need a healthy, slow population growth. I'm not saying we should grow without any control at a high speed, but we should have a steady, healthy growth. And why population growth rather than shrink will be better for humanity and for the planet. So stay tuned. Overpopulation myth. Let's start with the end in mind. The end. In 5 billion years, the sun will inflate into a red giant and will swallow the earth. Everybody dies. But much sooner than that, perhaps it's in 800 million years, maybe 1 billion years, the sun will start to expand before becoming a red giant and will increase the illumination, and that means the temperature on Earth will grow significantly, or the ocean will boil, everyone dies. So, unless humanity will be able to go to space and take as much of the biosphere with it and save other life forms, everybody is doomed. So, humanity are the planet's best chance to survive. What's on the agenda today? We'll have review the points that 60 Minutes interview with Paul Ehrlich put forward. We'll speak about Malthusian catastrophe predictions and why it didn't work, at least not in the last 200 and something years. A resource is a function of technology, superabundance, impact on the environment, habitats and climate, and before the end, population collapse, population growth and innovation, access to the healthy infinite resource of space, and fertility rates. What's going on right now on the planet? So the first point that we had on the 60 Minutes interview is that Ehrlich himself wrote a book in 1968, Population Bomb, and overpopulation would spread wide and spread famine, and a lot of people will die. It will be a catastrophe. So it's not 1970 or 1980 anymore. This prediction didn't come through. Actually, the opposite happens. The population is indeed been growing significantly since, the late 18th century, early 19th century. It come together with the industrial age. But in addition to the population growth, we also see that the food production grew up. The Malthusian theory that came very late in the 18th century by John Malthus, he came with the idea that resources are growing at a linear rate, or the size of the field where people can grow food, or the ability to grow food will grow at a linear rate, while population is growing in exponential rate. That means that according to Malthus, that at some point we'll have a huge population and not enough food to feed everyone, not enough resources to provide for everyone. And then we are going to have a catastrophe, starvation, wars over the declining resources. It's going to be a terrible time, a lot of death, a lot of war, a lot of people die of starvation, disease, whatever. But surprisingly, it didn't happen. What happened instead, that food production and industrial production, a lot of it is to do with mechanization in the industrial age, that we're able to grow more food, we were able to have tractors or combine, that were able to harvest large amount of land without as many people working in the fields. And we are able with fertilizers and genetic engineering that we were able to produce food that has a greater yield for the same acreage. And basically what happened is that it is true that the population grew at an exponential rate, but food production grew even faster. And not only that, and that's actually today we have less starvation than what we had 200 or 300 years ago. The number of people, actually we are in a situation where more people are dying of obesity than of starvation. There is still a lot of starvation in the world, but it's not because there is not enough food in the world, but because of tribalism and wars and politics that don't allow the distribution of food to everybody who needs it. So there is no really a problem of shortage of food, even though the population is indeed big. Next point of the 60-minute interview, Ehrlich have concern about mass extinction and loss of habitat. This point, actually, I totally agree with him, is right. We do have a loss of habitat, a lot of the landmass of Earth, at least the fertile lands, had been acquired by people or by livestock that come to have, that people are growing, like cattle, sheep, chickens, all the animals that we need are taking most of the fertile land in the world, and wild animals have a lot less. For example, 10,000 years ago, 99% of the masses was wildlife, and only 1%, perhaps even less, was humans. Today, only 1% of the animals are large mammals are wild, and most of the animals are either livestock, animals that are humans are growing for food or milk or fur or eggs, etc., or human themselves. So we have almost 8 billion people on the planet, and even more animals that we grow to serve us. So wildlife has a lot less habitat. Also, we have an issue with the overfishing and overpopulation. So in some areas in the sea, we took too many fish out of the ocean, and there aren't enough fish to refill the ocean fast enough, at least not as fast as we overfish. This point was also in the interview, and this point was actually correct. And also humans are causing climate change that could impact also the wildlife. So those are points I don't argue with it. The interview say, the TV program, the 60 Minutes, said that we do want to save 1/3 of the natural habitat, that only 1/3 of the Earth's fertile land is still natural habitat. We want to conserve that. Conservation is also important for biodiversity. There are so many animal, plants, fungus that we want to conserve. And so we want to keep the wild area. We want to stop the overfishing and the overhunting, poaching. We don't want to kill elephant for the ivory. We want to protect the rainforest, especially the Amazonas, that right now it's being destroyed at a very fast rate. And we want to put extra protection for animals that are endangered species, and take a caution to take action to reduce climate change. And we can do that. The question is, do we really need to eliminate, reduce, kill, I don't know, make sure that there are much smaller population in order to achieve that? Or can we do that with the current population, or even with a bigger population? I would agree that with the right rule and right conservation and right education, we don't need to reduce the number of people in order to achieve these goals. Next point in the interview, I'm actually quoting it. Ehrlich said the following: "We had it. Within the next few decades, we will be the end of the kind of civilization we're used to." Then the narrator, the interviewer in the show, we use 175% of the resources the planet can regenerate. 1/2 of humanity, 4 billion people, live under $10 a day, and they inspire to cars, air condition, and rich diet. But they won't be fed by the fishermen. They show in the show a fisherman that try to fish, and because they're fishing too much, the amount of fish depleted in the ocean, so that way they couldn't just continue to fish at the same rate permanently. But the implication of what Ehrlich and the narrator saying in the interview are two. First of all, we have too few resources to sustain the 4 million rich people on the planet who live in current Western lifestyle. Probably the planet can only sustain, if it's 175% or 4 billion, that means the planet can only sustain between 2 and 2.5 billion people. That's all. And we need to reduce the population to that amount. Furthermore, we need to maintain poverty on the planet. We don't want rich people, we only want poor people. These are the two implications of those statements. Next, Ehrlich said, humanity is not sustainable. To maintain our lifestyle, yours, mine, basically, for the entire planet, you will need 5 more Earths. Not clear where we're going to come from. The implication of this statement, since we have only one Earth and we had nearly 8 billion people, we need to reduce the population by a factor of 5, i.e., instead of 7.8 billion people, we should only have 1.5 billion people on the planet. No more, otherwise it's not sustainable. We'll run out of the resources, we're going to kill the environment. That's the implication of what he said. Thanos, the villain in Infinity War in a few of the Marvel movies, he had a similar thought. He thought there are too many people in the universe, therefore if we eliminate, he snap his finger and half the population will disappear, we'll have a better universe. But Thanos was not radical enough like Ehrlich. You only want to eliminate half the people, not 80% of the people. So let's review all this claim and one by one and see why at least I and a lot of other people think they are not correct and not true. First question, are we running out of space? So that's really not exactly what was in the interview, but let's address it anyway. The Earth's landmass is 510.1 million square kilometers. So assuming each person have only 1 square meter, which is a place to stand up, and I don't know, something like this, then we can only use the landmass and not build any building with 2 floors or high-rising towers. Let's say we just stand on a flat on the Earth, not on the ocean, everywhere on the planet. Then the planet can have at least a room, not food or resources, just a room for 510 trillion people. That's 65,000 times more people than what we have today on the planet. So we are not running out of room anytime soon, especially since we can build the high rising tower like skyscrapers with lots of people on the same landmass. So we are not running out of space. Are we running out of energy? Picture here is from Spider-Man. That's Dr. Octopus, who's trying to create fusion power. A total of 173,000 trillion of watts of solar energy that's solar power, strike the Earth continuously. That's about 10,000 times more all the energy needs of our planet at our current consumption rate. And that's not including putting solar satellite in space further away from Earth, then can collect more energy and transmit it to Earth. So we are still very, very far from a type 1 civilization on the Kardashev scale. So we are not type 1, not type 2, not type 3, or only, I don't know, small part. We need to increase the energy consumption by a factor of 10,000 to be a type 1 civilization. And in addition to solar energy, which has some issue, like you need a lot of storage, you need transmission from places that are the winter or at night. So you need to store the energy, you could use it all day. But we can have other renewable sources of energy, clean energy that are not causing climate change that we can use in addition to solar, like hydro, wind, geothermal, nuclear fission, and in the not too far future, if you heard the news, nuclear fusion, which is also what the op is trying to do here. So we are not running out of energy, though the transition to clean energy is needed, and we need to be able to capture a more significant portion of the solar energy that arrived to Earth. Are we running out of food? As we saw earlier when we discussed the Malthusian catastrophe that never happened, food is growing currently faster than the population. The reason why food is growing so fast, first of all, we have irrigation. We can bring water to fields from different places using pipes or different methods. We have fertilization. We can take oil from the ground, and we need the nitrogen. About 50% of the food we eat today come from nitrogen or ammonia from sources that are not natural, but something that we produce artificially, most of the cases from oil. And the third issue why we have so much food is genetic engineering. And I'm not included mechanized, like all the tractor and the combiners that can harvest a lot of food or grow a lot more food with a lot fewer people. So what happens if the population will increase significantly, not by a factor of 2, but let's say by a factor of 100 or 1,000? Well, in the not too far future, we're going to have artificial meat. That's meat that grows in a laboratory. Currently, about 70% of the agricultural land is used to grow food or for livestock, food for cows or for chickens. And the places that the cows and the chicken are roaming, walking around. So if we have artificial food that we can grow in a lab, then we don't need all this extra, or we can produce 2 or 3 times more food just by replacing meat with artificial meat. And we are going to have artificial intelligence and robotic that they can work and produce a lot more yield per acre, maybe in greenhouses. We can start using algae. So we can have more genetic engineering that will produce even greater yield and better recycling, better technology. So food production, probably we have a room to grow it. It's not going to be immediately. It's probably going to take decades or centuries, but we have room to grow a lot more food on Earth than what we do now. So that's not a limit. And right now we probably produce almost double the amount of food that we need in order to survive just in terms of calories. So we're not running out of food. What about waste disposal? Decoupling, if you take one device, like this device, it's replacing one cell phone, it's replacing camera, phone, alarm clock, calculator, watch, stopwatch, Walkman to hear music. It's doing a lot of job that in the past needed quite a few devices. Now we have one device to do it all. So we create a lot less recycle and still get to the same lifestyle. In the future, we're going to have even better devices that take less material to produce. And also we have better recycling methods. We're using artificial intelligence, robots that could do the sorting for us. So with better recycling, the planet can sustain more people. Next question. Are we continue to grow at the same rate indefinitely? The answer for that is not. No, fertility rate is in decline. Should we be worried? Yes, we should be worried. In order to maintain a stable population size, we need something like 2.1 kids per woman in the world. I'll move maybe the video per woman. So, and the population has been a decline. We used to have 5 point something. Let's go to the next slide. We used to have 70 years ago in 1950, 5.9 kids per woman. That's the average for the world. And today it's only 2.4. So there is definitely a decline. And probably in the not a very long future, maybe in one generation from now, If the trend continue, we will have 2.1 kids per woman, and then even less, which means two things. First of all, we're going to have fewer younger people. That means a large old population and few young and a lot of old people. And eventually the population size is going to start declining. It is possible that after 2050 or maybe 2100, the year 2100, the population will reach its zenith and then it will start to decline. Maybe it's something like 9 billion, maybe 10 billion. It depends on how the future is going to look like. But we're not going to have a population explosion. The fertility rate is in decline. We're going to have fewer kids and potentially fewer people. The distribution here is Japan. We see Japan in 1950 that has a healthy population, pyramid like it should be, lots of kids, then a smaller amount of young adult, and smaller amount of adult, and not too many old people. Now it's kind of upside down, almost upside down pyramid. We have very few kids, and most of the people in Japan are between the age of 50 and the age of 75. It means a lot of older people or people that are about to retire, and very few number of kids. This is going to cause a lot of economic problems, and in the further into the future, population. I think that in Japan already the population started to shrink, but we'll have the same thing in a few decades in the entire world. So the entire world population is going to be old and start to shrink, which is bad for the economy and bad for a few other reasons. Next topic, space. There are nearly infinite resources in space. So once we go to space, let's say we have a stable population and we can start sending tens of thousands, maybe millions, maybe tens of millions, maybe hundreds of millions. A lot of people, especially if we have something like Star Trek technology, a lot of people will be able to go to space. So that means there is not going to be any overpopulation issue on Earth. And if we are shrinking population, then we don't have the people to send to space. And people who have a concern about the amount of resources here on Earth, well, yeah, there are much more resources in space. So if we go there, there is no overpopulation issue at all. We can have probably just in the solar system, in O'Neill cylinders, in the Earth cloud, probably could have many trillions of people on just in the solar system, and that's before we go to interstellar to other star systems. And the next point I want to bring is that resources is a function of technology. It's not a fixed amount, and this is the main reason why the Malthusian catastrophe never happened. So with a bigger population, we will have more innovation, we'll have more Einstein, more scientists, more people who come up with new idea. If we have a smaller population, especially shrinking population, most of the people are above 70, then they will have less innovation. So we will not be able to invent all this new thing that will allow us to harness more solar energy and do better recycling and better food production and better lifestyle and allow more people to have higher quality, become richer. So one example why resources and the ability of the planet to sustain people is not a fixed amount, but a function of technology is we go back to the Stone Age. 10,000 years ago, in the year 8000 BC, the planet could only support a population of about 3 million people. Most of them were hunter-gatherers, and if you had more people, then all the mammoths will become extinct, and then there will be no mammoth, and people will starve to death. So the population could only be a handful of million of people in the entire planet. With the Bronze Age came agriculture. So on the same landmass, on the same field, we were able to grow a lot more food, maybe 100 times more food, and this could sustain 100 times more population. So in the year 1000 BC, the planets could have something like 300 million people. And then came the Industrial Age. Industrial Age, we have mechanized, we have tractors, we were able to heat and have more energy. and the population grew to 1.6 billion people. Today we have 7.888 billion people, nearly 8 billion people. And if we have renewable energy, space, artificial intelligence, robotics, genetic engineering, and advanced recycling, the planet could support a much, much bigger population than 8 billion. I don't know, I saw some video, perhaps even a trillion. I don't know, I'm throwing a number. But since with Stone Age, you can have fewer people, with agriculture, you have more, and with industrial age, you can have what we have right now. With future technology, with super advanced technology, you can have a lot more people than what we have today and do it in a sustainable way. Conclusion: the Malthusian theory was proven wrong again and again and again since it came out in the 18th century. It could be right in a petri dish, like if you have a stagnated technology or everything is fixed, then you're right. But if we have innovation and we can use from the same land and the same energy, you can produce more and more and more, then this theory will not work. So the biggest problem of this theory, it ignores technological advances. The number of humans on the planet can sustain is a function of technology, and it's not a fixed amount. This is why the Malthusian theory is wrong. For better technology, we need innovation. And in order to have more innovation, we need more people. So this is counterintuitive, but it is possible that if we have more kids and more people, it's not huge amount, like not 10 kids per family, but let's say something between 2 and 3 kids per family. So that we still have the pyramid, slow, steady population growth, with more young people going to school and study. We can have more innovation. And like this one small device was able to replace 5 devices. Let's say if the population is 20% more and we have more innovation, maybe it can save 5 times more than they're worth. So we could be in a situation that a bigger population will cause less damage to the environment than a smaller population just because we have more innovation. Population growth is slowing down, and in the not too far future, we may enter a population decline or perhaps even a population collapse. I did a video and I'm going to put it in the links in the end. You can watch about the video about population collapse. But if you have a concern about overpopulation and the population may actually shrink in 20 or 50 years from now, then it really should not be a concern. And we may soon be able to go to space and have access to the nearly infinite resources of space, which will solve every problem, imaginary problem that we still think that overpopulation may have. So if you're young people and you have doubts that you don't want to bring kids because it's bad for the planet, don't worry about it. You're not going to destroy the planet by having 2 or 3 kids. So thank you very much. This is a link to my blog, my Twitter name, and thank you. Don't forget to watch the population collapse video, and see you on the next video. Thank you, and don't forget to click and subscribe. Bye for now.